looking at this problem from section 7.3. Asks us to approximate the area under a curve and above the x-axis using 3 different methods, and then averaging 2 of them in the third part there. With 4 rectangles, it's a linear function, so let's take a look. I've got a drawing here about how we can approach this. So here's the function 6x plus 7. I've kind of I've changed the scale a little bit here so I can fit it on here. We're only interested in what's happening between 5 and 7, so that's all I've got on the x-axis here. And then if you plug in 5 here, you got 37 as an output, so I just sort of cut out this part right here and this part right here just so we can see the graph. And then if you plug in 7, you get 49 for the output value, so we're looking at a linear function between these 2 points. That's kind of what it looks like, just sort of focused in right there. So what I've got drawn here on the left is the left endpoint approximation. So what that means is we're going to be plugging, we've got 4 rectangles. Since it's only 2 wide here, each rectangle has width 1/2. And so with the left endpoint, the first one we're going to plug in is right at the very left end of the interval at 5. That gives a height of 37 for this rectangle here. Okay, and again, each one has width 1/2. That's going to be needed. And then 5.5, we plug in our next left endpoint. That determines the height of the next rectangle, and so on until we get to the last. The fourth rectangle will be determined at height, or determined by the output at 6.5. So whatever that output is, that's how high that last rectangle is. So we can figure that out. In fact, yeah, let's just go ahead and do that, and then we'll come back to this other drawing here. So with the left endpoint approximation, we'll get the first output is at 5, so we'll say f of 5, and then plus the next one is at 5.5, so f of 5.5, and then next one's at 6, and finally 6.5 is the last one. Okay, so these are the heights of each rectangle, and then we're going to multiply this by the width, which is 1/2. Let's put 0.5. Okay, so what is f of 5? Well, f of 5 is whatever we get when we plug in 5 to this thing here. So f of 5 is 37. F of 5.5, what we get when we plug in 5.5 here, and that's 40. And then f of 6, if we plug in 6 to this function, again right there we get 43. And then 6.5, if we plug that in there, we get 46. And then we have to multiply all of that by 0.5. And if we do all that, we get 83. So 83 is a left endpoint approximation. We see that's clearly an under approximation since we were missing all that area right there. For the right endpoint approximation, what we're going to do is plug in the right endpoint, and that will, of each subinterval, that will determine the height of each rectangle. So I'm just going to do that right on top of this one. If I do that, then I have to make the rectangles actually go backwards to the left. So my first rectangle would look like that, second one like this, third one like this, fourth one like this. So all of these are clearly larger over approximation. So to find that right endpoint approximation, we're going to say now we're starting the first one that we actually plug in to determine the height of a rectangle is at 5.5. So we say f of 5.5 plus f of 6 plus f of 6.5, and then the last one, right endpoint, we actually plug in f of 7 for the last one here. So we're kind of just shifting everything over for that right endpoint approximation. Okay, we've already got 3 of these values, so let's just go ahead and use the same one. So that's 40 plus f of 6 we said was 43, f of 6.5 was 46, and f of 7, if we plug 7 in there, that's 42 plus 7, that's 49, so plus 49. and I'm forgetting to multiply all this by 1/2. I need to do that too because that's the width. So multiply this by 0.5, and that gives us 89. Okay, so that's the answer to part A and to part B. And then if we want to answer part C, we want the average of these two. So average of the left and right endpoint approximations is 89 plus 83 divided by 2, and that is 86. So there's the first three. Now for the midpoint approximations, we have to do it a little bit differently, so I've drawn a different one over here. What we're going to do there is we have to look at the midpoint of each subinterval. So in this case, remember that each subinterval has a width of 1/2. So now we're determining the height of each rectangle by the exact midpoint of each one. So this midpoint right here, that's 5.25, and that determines the height of this first rectangle. So we'll say for this one, sort of block this one off here. So for the midpoint, we're going to say it's f of 5.25 plus, now the next one, 5.25, that's 5.5, so that's 5.75 is the next one. And then the next one after that, 5.75, 6, 6.25. Okay. And then the last one, 6.5, that's 6.75. So f of 6.75 is the last one. Okay, and then again we have to multiply all of these again by 1/2 because the width is not changing, so we just squeeze that 1/2 right there. Alright, so if we put all this together, we're going to get 1/2 times f of 5.25, and all these together will be all of this, 38.5 for that one, 41.5 for that one, 44.5 for that one, 47.5 for that one. And then if you add all these up and you multiply them by 1/2, you get 86. Same exact answer. And on the previous one of these problems, we already actually had seen that if you have a linear function, then the midpoint approximation actually gives the exact area under the curve. So what we do have here in both cases is the exact area under the curve. But anyway, to answer all the questions, part A, 83, part B, 89, the average of the two, 86, and then the midpoint, also 86.